Hey everybody, welcome to Coffee at ChemEng. Today we have Raminus. Raminus won a prize at the recent SUCES Innovathon, and it was really inspiring his story. And Raminus is in first year, and my understanding is, things happened, it didn't go as expected, and then you were the team, and you still rocked up and did your best, which I think is really inspiring. So thanks for agreeing to be here.
Thank you so much for inviting me.
And you wanted to tell everybody about the project that you worked on, so please tell us all about it.
So currently, Epsiode is recycling the lithium-ion batteries that are being wasted in Australia. So the current method they're using to recycle those batteries use conventional hydrometallurgy and pyrometallurgy. And those methods are very energy consuming. And one of the main reasons they wanted to collaborate with SUCES was to find out more ways how they can eliminate the generation of PFAS-contaminated wastewater, as the current methods generate a lot of PFAS-contaminated wastewater.
Right, okay.
Yeah, so it's not environmentally sustainable currently.
So a lot of problems to solve currently.
Yeah, so this problem was a very broad problem, and as we had to delve very deep into the method they're currently using and how they're breaking down the batteries and everything. So the main things that we wanted to implement in the new method was firstly manual handling and manual breakdown of the batteries that would prevent the loss of the solvents and metals that using hydrometallurgy or pyrometallurgy was doing, because they were burning it, right? So when they're burning it, a lot of it is being lost, and a lot of solvents are being lost because of the very high temperatures.
Right, okay.
Yeah. Okay. So firstly, we wanted to integrate a pyrolysis of gas condensation. So what that would do is, when they're rising the temperature of those materials, the gas is condensed back so that the solvents aren't lost. Right? And then we wanted to use ultrasonic waves to remove the PVDF bindings and all those things from the cathode and anodes, so that a lot of PFAS contaminated wastewater is not being generated, because when they're using hydrometallurgy, a lot of HFs and fluoride related solvents are dissolved in the solution, and as a result, a lot of PFAS contaminated wastewater is generated. So we wanted to eliminate that using ultrasonic waves. And then finally,
hey Eunice, no worries, we're finishing. This is life.
But finally we used orange peel biobleaching to bleach and extract those solvents and recover those metals.
That is brilliant. I can see why you did so well. Alright, there's a meeting happening, so we have to cut this short. And I should mention one thing, which you didn't plan on, which I just found out. You wanted to be a chemical engineer since you were 4 years old.
Pretty much.
That's my main takeaway from all of this. That and the amazing ChemEng. Well, thank you so much, Raminus, for agreeing to be here, and you have a really bright future. And I hope it inspires all the other first year, second years, and everybody. Alright, okay, thanks everyone. Bye.